What's up, skaters? We are going to talk about two types of functions today, how we can transform them, and how to graph them. So let's go ahead and name them first. First one we're going to do is a quadratic. Why doesn't my pen work? Hold up, hold the front door. There we go. Quadratics. So quadratics are anytime you have f of x equals x squared, and you can do some extra fancy stuff over here, but that's what really makes it a quadratic, is having the squared x. And what those are going to look like are either u's like this or upside down u's like this. Okay. The other one we're going to look at is an absolute value. So absolute values are anytime we have f of x equals and then x inside an absolute value. And those are just vertical bars. And these are going to look similar to this, except a little pointier. They're going to be either v's or upside down v's, like that. So we're going to learn how to transform these. And when we say transform, we're not talking about taking a u and turning it into a circle. That's not it. We're talking about taking a u and then moving it and maybe flipping it upside down. And that's about it. So we're going to translate it, which is sliding it around, and we might flip it, and that's it. Okay. Same thing with our absolute values. We're going to learn how to slide them around and flip them upside down. All right. So before we look at these specifically, let's go talk about how the transformations work so that you know what you're looking for. Okay. This says f of x equals a times the quantity, that's how you say the parentheses fancy, x minus h, close parenthesis, squared plus k. So first of all, I don't want you to get really hung up on this being squared. This could also be the absolute value instead of the squared. What we want to pay attention to are the a, the h, and the k, and what they do, because those same three variables are going to be used for the exact same transformations for the rest of this lesson and tomorrow's lesson. So let's go ahead and discuss those first. For a, this coefficient in front of the parentheses or outside the absolute values has a couple of things. If a is negative, it's going to reflect in the x-axis. That's a fancy way for saying flip it upside down. Okay. So if we have f of x equals negative x squared, instead of being a u, it's going to turn into an upside down u. This negative sign is going to flip it. If a is a number, like it's a 2 or a 3, it'll stretch it. And if it's a fraction, it'll shrink it. Okay. I don't think we're going to look at this too much today. We're going to mostly focus on the flipping aspect. All right. Now, h and k. H is going to be our horizontal shift. So it's going to take our graph and move it left and right. And what you want to remember is that h is a liar. And you know what I mean. A liar, right? Like your ex-girlfriend or boyfriend when they said that they were just going to the mall with some friends when really they were not just going to the mall with some friends. Like that. So whatever they say, they mean the exact opposite, just like your ex. So if we have a negative h, normally on an x-axis, left is negative, but a negative h is going to move the graph to the right. If we see a plus number inside the parentheses, that's going to move the graph to the left, even though normally to the right is positive. So whatever you see in here, it's going to be backwards. Okay. K is for vertical shift. That means it's going to move it up and down. K is like your current boyfriend or girlfriend. Super honest, super loyal, never lies to you. So when K is positive, it moves in the positive direction, which is up. When K is negative, it moves in the negative direction, which is down. All right? So those are the three ways we're going to transform graphs. In the wild world of mathematics, there are way more ways to transform, but this is what we're going to focus on. All right. So let's go look at some equations and see if we can predict what or name what the transformations are going to be. Okay. So let's look at this f of x transformation right here. They want us to describe the transformation from from f into g. So how did I get from here to here? Really what they're asking is what transformations are happening in the g equation. So we don't have a negative in front, so there is no a term. Here we see minus 5. So inside the parentheses with the x is the h. That's our horizontal shift. So we're going to shift in a direction horizontally 5 units. Because this is negative, that's telling us to go in the positive direction. Positive on the x-axis is to the right. So this minus 5 on the inside will shift right 5. Okay. Now we look at this number outside the parentheses being added or subtracted to them. This is our k value, which is our vertical shift, which is up and down. So because this is a negative, we're going to go in the negative direction, which is down. So we're going to go down 3. Shift down 3. And that's it. Those are our two transformations. Excellent. All right. Let's look at this other example here. Same idea. We want to know what transformations are happening to this g function compared to the f function. So now we have this negative sign here. So what we're going to say for this negative sign, it's going to take our parabola and flip it upside down to be a u. So we're going to say reflect vertically. Okay. I'm not sure who wrote your homework. So let's just talk about other ways this might be said. They might say reflection in the x-axis. I feel like this is an inaccurate way to say it, but I didn't write your homeworks. I only helped write some of them, and it wasn't that one. So you might see this reflect in the x-axis. That's the same thing as reflect vertically or flip. They all mean the same thing. Now we have an h value here. Remember, h is a liar, so we need to switch the sign. So this is actually -2. Negative in the x direction is left. So we're going to go left 2. And we should, whoops, left has a T. We should probably say shift left 2. And then our k value is right here. K is up and down. Because it's positive, we're going up and we're going 9 units. All right, last one. Now we have an absolute value here, but absolute values work exactly the same way as quadratics. So this negative in front is still our a value. So it's an invisible 1. So it's -1. This is going to reflect vertically. Inside we have a -9. This is our h value. It goes the opposite direction. So this says minus. We're going to go in the positive direction. Positive is to the right. So we're going to shift right 9. And here's our k value. It's a -12. So we're going to shift. How do I write letters? Shift down 12. Okay. So that's just describing the transformations if we have an equation. Let's practice if we have the transformations, how do we get the equations? So let's try it that direction. Here it's asking us to write the equation of the given function with the given transformations. Okay. Let's start with the basics that you're going to have for everything. F of x equals, now we need to read a little bit, the absolute value. So let's go ahead and put our absolute values. Let's put an x in it. Now we need to read our transformations. This could be shifted left 7 Left and right is the h value. Left is usually negative, and h has to be backwards. So we're going to put plus 7 in the h position. Then we need to go up 3. This is a k value. And remember, k does not lie. Up is positive, so we're going to put plus 3. And then that's your equation. All right, let's try 2 more. F of x equals a quadratic function. So we're going to put some parentheses, put an x inside, and square it. Now we need to look for our transformations. Shifted to the right 6. Left, right is h. Right is normally positive, so we need to do the opposite. So minus 6. Down 1, this is our k value. Down is negative, and k should be the sign that it wants to be. It doesn't lie. So if we're going negative, we need to put negative 1. And there you go. There's your equation. Pretty straightforward. Now, the absolute value graph. All right, so let's f of x. Put our absolute value. Put an x on the inside. Shifted down 10. All right, they're trying to trick us here. They changed the order. This is k. K is up and down. Down is negative, so we're going to put minus 10 on the outside of the absolute values. And reflected across the x-axis. Again, this means reflected vertically or flipped upside down. So we don't have an h value. There's no horizontal shift. This is an a value, and it's just telling us to make a, whoops, that's not what I wanted. Let's try to make a negative. So we're going to put a negative sign in front. If you want to rewrite this so that you don't have this big gap here, that's fine. There we go. Looking good now. So there's our equation. Excellent. Not too bad, right? All right. Let's go look at a tricky one. Okay. Here, they want us to create a function, g of x, that's translated, but not from a parent function. Instead of starting at f of x equals x squared, now f of x is this goofy thing here. So what we need to do is we need to figure out what the transformations are, and they just tell us right there, but we need to figure out h and k and that stuff. Then we're going to write the transformations in the correct position, and we're going to simplify with what's already there. Then we're going to change the function name to match what they want. Okay, so let's try that. So let's figure out what our transformations are. Let's find h and k. Left 7. So this is h. Remember, left is usually negative. We need to change the sign. So we're going to put plus 7 where the h value goes. Here's h. We're going to put plus 7. Up and down is our k value. Up is positive and 2. So we're going to put plus 2 where the k is. Now we need to simplify with what's already there. Don't worry that this is in parentheses. We're just changing the h and k to have these transformations. So 1 plus 7 is going to be 8. So we put x plus 8 squared. And then negative 4 plus 2 is negative 2. Now this equation has been moved left 7 and up 2 from this equation. Okay, so we wrote the transformations, we simplified. Now we just need to change the function name. They want it to be called g of x, so we'll put g of x equals. And then this is our answer right here. Not too bad. Easy peasy lemon squeezy. I believe in you guys. You can do this. Let's try another one. Ignore these steps. I forgot to change them. We're going to use the same steps as on the last one. Here, I'll even, let's change them so that you guys don't get confused. Whoops, get rid of these two. Delete that. Watch this. The miracle of teaching in 2021. Copy. Paste. Check it out. There we go. Now we have the right steps. So first thing we need to do is figure out our transformations. So vertical reflection. That's an a, and we need to turn it into a minus sign. So we're going to put a minus sign in front of this. Left, this is h. Left is normally negative, so we need to change it because h is a liar, so plus 1. Up and down is k. Up is positive, and 6. So let's go put these on this and then simplify. So we're going to put a negative in front. We're going to put a plus 1 where h is. We're going to put a plus 6 where k is. So this is going to become negative, the absolute value of x. Negative 8 plus 1 is negative 7. Close the absolute value. 2 plus 6 is 8. We wrote the transformations in the correct position. We simplified. Now we have to change the function name. They want the new one to be g of x. And we're done. Good job. Okay. Now what we're going to do is we are going to graph the equation. We are going to identify a, h, and k. And we're going to say where the vertex is. And we'll talk about that in a second. So let's first start with graphing the original. Then we'll worry about this stuff here. For the original, f of x equals x squared. What I recommend is starting with an xy table. And let's just graph the parent function. So let's pick some x's. Negative 2, negative 1, 0, 1, 2. And these are just random values I picked. We got a couple negative, a couple positive, and 0, just to get all the interesting bits. Now we're going to plug them into this parent function, just so we can learn what the most basic one looks like. Then we're going to apply this transformation to it. So if I take negative 2 and I plug it in here, we're going to have f of negative 2 equals negative 2 squared. That's 4. Okay, 4. So what you can see is we're just squaring this number. So negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So let's go plot these. These are ordered pairs. So negative 2, 4. 1, 2. 1, 2, 3, 4. There's 1 point. Negative 1, 1. Left 1, up 1. 0, 0. 1, 1. And then 2, 4. Okay. If we want a few more points, we could also put 3 on here. So 3 squared is 9. And then we could go backwards, right? We could put negative 3 on here. Negative 3 squared is also 9. So we could go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, up 9. So this is a really good graph. Ooh, it was a really good graph till I got a little shaky there. Of our parent function, this is just f of x equals x squared. Now let's check our transformations. Okay, so a is the invisible coefficient here. It's just 1. H is this number, but we have to change the sign. So h is 2, right? Because h is a liar. And then k, we're not adding or subtracting a number here. So that's 0 because there's nothing there. The difference between there being nothing here and nothing here is k gets added. If we say plus 1, that changes something. That goes up 1, right? Whereas if we do plus 0, if you have $5 and I give you plus $0, nothing changes. You still have $5. So because this is addition, we need to do 0. A is multiplying. So if you have $5 and I multiply by 0, 5 times 0 is 0, and now you have less money. If we take 5 and multiply by 1, then you still have 5. So the difference here is the math operation that these two numbers are doing. Because A is multiplying, we need it to stay the same, so we multiply by 1. Because K is adding, we need it to stay the same, so K is 0. All right. So our vertex is a fancy name for that point right there. It's where the U is at the bottom. It's a minimum. Your vertex is always going to be at the ordered pair H, K. So for this one, f of x, ours is going to be at 2, 0. Okay. So the transformation being applied here is we're going to go right 2 because of this h value. So you can either look at the parent function and then move all these points right 2. So we could do that. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And then we can get our new graph. Good? Okay. Hopefully not too bad. You should probably spend a little bit of time trying to memorize this. I understand. Math is awful and you hate math and you think that this is totally worthless and you're never going to use it again for the rest of your life. And you're so convinced of that fact that you're actively going to try and avoid this for the rest of your life. I get where you're at, kid. But you've got to pass the test in a couple of days, right? So you probably need to know this at least for the rest of the test. So I would memorize this for the test, the parent function, and then it's pretty easy to transform. Okay. All right, so let's do a little bit harder one. I'm going to go ahead and put my parent function on the graph. 0, 0, 1, 1, negative 1, 1, right 2, up 4, 1, 2, 3, 4, right 3, up 9. So it's however far left or right you go up that much squared. So left 2, what's 2 squared? 4. 1, 2, 3, 4. Left 3, what's 3 squared? 9. Okay. So here's our parent function. Okay. So let's go look at our transformations here. Again, A is 1, so 1. H, remember change the sign, is 4. And K is this number, keep the sign, negative 2. So our vertex is going to be at 4, negative 2. And what we're doing is going right 4 and down 2. Okay, so let's go move all our points. We're going to go right 1, 2, 3, 4, down 2. Right 1, 2, 3, 4, down 2. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. And then now you can kind of see the pattern, right? So the next one's right 1, up 1. So right 1, up 1. Then right 1, up 3. Right 1, up 3. And you can double check these, right? 1, 2, 3, 4, 1, 2. Oh, look, it's in the right spot. 1, 2, 3, 4, 1, 2. And do you notice how these are always the same height? These are always the same height. These are always the same height. So there's a couple of tricks you can check to make sure it's in the right spot. So there's our new parabola as best we can draw it. Okay. If you were in person, I'd really encourage you to put these points on there really big so they're readable. Because if you're like me and you have the dexterity of a 5-year-old, do you see how wobbly your lines are? If you miss points and you just draw like this, I have to go with what this line looks like. Whereas if you put ordered pairs, I can kind of tell that you just have wobbly hands, right? So if we were in person, it would be really important for you to make sure that these points are on there. I think on your test, it's going to be multiple guess. So it's probably not that big of a deal, but you know. Also, on your homework and your test, you have Desmos built into that. You can just put this thing in Desmos and look at a picture of it. Okay. All right. Let's talk about absolute values, and then we'll get you on your way. So let's start by talking about the parent function first. So the parent function, which is a fancy way of saying the simplest function that will transform to get all the other ones is f of x equals the absolute value of x. So let's make another xy table. Let's plan ahead a little bit this time. And we'll do from -3 to 3. And this works for really any function. Later in life, when you're in college and you're studying math because you changed your mind about wanting to be whatever you wanted to be, your rap career on SoundCloud really didn't pan out the way you thought it would, and you're like, man, I gotta take math again? That stinks. You can use this. If you just plug these numbers in to x, pick any ones you want, and then simplify, it'll tell you where the y's go, and then you have word pairs. So if we plug in -3, the absolute value of -3, absolute values just make stuff positive. So it would be 3. Absolute value of -2 would be 2. And you can guess the pattern, right? 1. Absolute value of 0 is 0. If it's positive or 0, it just doesn't do anything. The absolute value of 1 is just 1. Absolute value of 2 is 2. Absolute value of 3 is 3. So it's however far left you go up that far. And however far right you go up that far. Okay. So now let's find A, H, and K. Let's find our vertex. It's still going to be HK. And then we'll graph. Actually, let's graph our parent function first. So we've got 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. -1, 1, -2, 1, -2, 2, -3, 3, -4, 4, and so on. So absolute values are just going to look like a V. Okay. Now we're going to find our A, H, and K, and then we're going to transform these points. So we're going to go, A is -1, so -1. H is this number, change the sign, so -7. And K is 4. So our vertex is going to be at -7, 4. Okay. So let's go put our vertex on the graph. -7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So now we could probably guess. This is the vertex, so you could just go up 1, right 1, up 1, right 1, up 1, right 1 to get the rest of these dots, and up 1, left 1, up 1, left 1, up 1, left 1 to get these dots. But this is going to flip it upside down. So instead of going up 1, right 1, it's going to go like this and be an upside down V. So let's just make an upside down V from our vertex. Dot, dot, down 1, right 1, down 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. And then there's our new absolute value graph. Whoops, that's a little sloppy. Anyway, you would use a ruler, but there we go. Okay, looks good. So there's our absolute value. Let's do one more for practice. All right, A, there's no number here, so it's the invisible 1. H is this number, change the sign. K is this number, keep the sign. And our vertex is at 1, -3. All right. Here's our parent function. It starts at the origin, and then it goes out diagonally. Right 1, up 1, right 1, up 1, repeating forever. Left 1, up 1, left 1, up 1, repeating forever. Okay. Now our vertex is at 1, -3. So right 1, 1, 2, 3. And then it's not flipped this time. This is still a positive 1. So no flipping because it's positive. So it's just going to slide this whole thing right 1 down. So it'll have the same shape. So we can go up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And then we get our new graph. And there you go. Not too bad. So I encourage you, please take advantage of the Desmos graphing calculator. It will help you so much with this lesson. If you are having trouble, I'll be in class with you. Ask me questions. Don't just sit there and say, Mr. Barton, I really hate math. I'm going to log off and go smoke cigarettes with my friends behind the Circle K. Don't do that. Ask me for help. I'd love to help. If you don't ask me to help, who knows what I might do? I might go smoke cigarettes with my friends behind the Circle K. And I'm not trying to die of lung cancer. So please ask me for help. Until next time, have a great day, you guys.